Hello, math students. Welcome back to Module 2, and it's called Rational Numbers. This is Lesson 11, and it is called Writing, Evaluating, and Finding Equivalent Expressions with Rational Numbers. And that is the title. It's kind of a long one, sorry. Writing, Evaluating, and Finding Equivalent Expressions with Rational Numbers. Our goal for today we will practice writing expressions that represent real-world situations. So we have been talking a lot about understanding the difference between positives and negatives and rational numbers and what makes a rational number and all of that kind of stuff, and multiplying and dividing them, and the commutative property, the associative property, the distributive property. We've talked about adding and subtracting rational numbers and integers, and today we're going to take all of that information and put it together in order to practice writing expressions that represent real-world situations. The question that I want you to be thinking about is, what is an expression and how do you create one? So things to remember. Remember that expressions take the place of words in math, and remember that an expression is a math sentence that uses symbols, but the only thing that it does not have is an equal sign. So we're going to keep that in mind when we're working with this problem, because you have to create an expression, evaluate means to solve it, and then find an equivalent expression that has rational numbers in it. Okay, so let's practice. SMS Spring Dance is coming up. It costs $1 to enter the dance. Snacks at the concession stand cost $2 per snow cone. Ryan came to the dance with 3 friends. They all bought a snow cone. How much total money did they spend? So if we're looking at this with it being the spring dance, we know that to get into the dance, it costs $1. So I'm going to write this down. So we have $1 to get in. Okay, and then it says snacks at the concession stand cost $2 per snow cone. So we now know that we have $2 for every one snow cone. Okay. And then we know that Ryan came to the dance with 3 friends. So in total, if Ryan has 3 friends and you include herself, that's total of 4 people come to the dance. So 4 people come to the dance. Okay. And now what we need to do is we need to create an expression that will help us figure it out. So we know out of the 4 people who came, they each have to pay $1 to get in plus $2 per snow cone, right? And so could we write an expression, this is an expression because you don't see an equal sign anywhere, could we write the expression to look like this? And the reason that I did that is because we've been spending a lot of time working with the distributive property, and this is the distributive property. So what it's telling me to do is that for each person that is coming to the dance, they have to pay $1 to get in and $2 for a snow cone. And how many people came to the dance? Well, in this specific scenario, it says Ryan and her 3 friends. So I know that in total, that's 4 people that came to the dance that are buying a snow cone and actually coming inside to the dance. So I'm drawing a tape because a lot of you said that tapes really help you see it. So this is to get in, the $1 to get in, $1 to get in, $1 to get in, $1 to get in, $2 a snow cone, snow cone, snow cone, snow cone, and then it says how much total money did they spend? Well, that's not bad because now I just add up the dollars to get in. So I have 1, 2, 3, 4, $4 to get in, right? Plus $2 per snow cone, so 2, 4, 6, 8. $8 for a snow cone, and so what was the total cost of the whole entire adventure? $12 for the 4 people. Okay, so it cost them $12 to come to the dance and each get a snow cone. Did we answer the question? Yes. Did we write an expression to represent what was going on? Yes, and the rational numbers were that it was $1 and $2, so that helped us with the rational numbers. Did we use the distributive property to help us? Yes. Okay. Did we evaluate it? We found the answer, so yes. And did we find an equivalent expression with rational numbers? Yes. So we could say 4 times the quantity of $1 plus $2 equals $12, and those are two expressions that equal each other. So let's write that out to make sure that you understand what I'm saying. So 4 times the quantity of $1, right, plus $2, all of that when we figure that out equals $12. Okay, and so this right here, this whole thing right here is an expression, right? Expression. And this right here is an expression. And so if we go back to our title, it says finding equivalent expressions with rational numbers. That's definitely what we did, because this expression equals this expression. So we were able to do that with our goal. So our goal for today we will practice writing expressions that represent real-world situations. We totally did that with the dance at SMS. What is an expression and how do you create one? An expression is a number sentence with symbols and no equal sign. So this right here is an expression, and this right here is an expression. When you have the equal sign in there, the whole thing, so I'm going to circle this whole thing right here becomes an equation. And the reason why we know that it becomes an equation is because equations do have an equal sign. And 4 times the quantity of 1 plus 2 equals 12 becomes an equation, that whole thing. What makes up an equation? An expression, an equal sign, and another expression. So there's 2 expressions in this one equation. Okay? So that was kind of a review of what those were as well. All right, kiddos, I think we met our goal. We practice it in a real-world scenario because you guys have been to the dances at SMS, and that actually is true information. You set up expressions, you evaluated them, and then you found one that is an equivalent one with another. So I definitely think that you practiced your goal for today. That's all I've got. Talk to you soon. Bye.